Up next is a pragmatic guide to AI and machine learning, one of the hottest supply chain topics. But before we explore how AI and machine learning will help, we need to talk about data. And that is exactly what Josh Mann, Director Product with RELEX, is going to share with us today. So welcome, Josh.
Hello, good to be here. Okay, so without further ado, the start of every good presentation is with some arbitrary numbers, of course. So 1955 is the first one. So this is when John McCarthy first coined the phrase artificial intelligence. And it's actually 5 years after Asimov wrote I, Robot. So artificial intelligence, the theory, the concept, the ideology has been around for a long time. 50 quintillion. So this is the number of possible moves on a checkerboard. I don't know about you, but I can't think of more than about 7 things. So 50 quintillion is quite a lot. And it's something that AI has practically solved. And if you look up the Chinook robot, Schaefer and Tinsley after this, it's a very good read about exactly how that came to be. $16 trillion. Now, this is the impact AI will have on the GDP by 2030, according to a McKinsey report. That's an increase of 16%. So this is a pretty big deal. And then 20.6 billion. And this is the AI in retail market, according to a Facts and Factors research paper by 2026. So what we're identifying here is that the concept of AI has been around for a long time. It solves very complex issues, and the hype isn't going away. It's a big business, it's a big value add, and it's a big driver for how we think about managing retail, but not just retail, also wholesale, manufacturing, and other areas as well. Okay, so what we're going to focus on today is we're going to briefly touch on what is machine learning and AI. Then we're going to talk about exactly how it can help within the retail, wholesale, manufacturing area. Then we're going to talk a little bit about how it works, and then finally, how it's actually applied. Okay, so what actually is it? So there's a couple of schools of thought around how machine learning and AI kind of work together and correlate with one another. So the first is the AI perspective, of which machine learning is under the umbrella of AI, closely linked with deep learning, which includes things like data mining and other concepts like that. But then there's another perspective, which I tend to adhere to, and I think we do at RELEX, which is that machine learning is a subset of artificial intelligence alongside many other factors. Things like robotics and heuristics also play into this kind of description of what machine learning actually is. So AI is the umbrella term, machine learning is a subset, a component of that, and they often get conflated in various different descriptions. So if we think about that alongside what we're used to from a traditional programming standpoint, we're used to a situation where there's an input, there's a rules-based program that generates an output. Time series forecast is very similar to that. We understand the components that go into that. With machine learning, we train algorithms based on an input and a known output that creates a program or a model, which is then used in the future to feed in the output and generate the likely output or based on those data points. So that's where the whole concept of learning comes into play. And there's several different varieties to that: supervised, unsupervised, and reinforcement. We'll touch on some of those factors a little bit later as well. So that's your really brief kind of history of machine learning, or description of what machine learning actually is. So let's talk a little bit more about how it can actually help. Okay. So the current focus, not just of retailers actually, this goes across wholesalers as well as the manufacturing industry as well. But the current focus is obviously on cost saving, the last 18 months more than any other, enhanced decision-making and process automation. This slide is not revolutionary information. You all know about this. This is the focus of what we're trying to drive. And it's something at RELEX that's core to our ideology and the improvements that we're trying to add to any business that we interact with as well. So how does AI really augment that and help that? Well, firstly is through better forecasting, which leads to better inventory management, leads to more money saved, whether that be in working capital, whether that be in reduced spoilage, or whatever it may be. Now, I'm going to be touching on forecast a lot during this session, and that's because it is the most predominant use case for AI and machine learning algorithms. The reason for that is twofold. One, the forecast drives a lot throughout the retail kind of operational process. We're talking about unification and a couple of other sessions that you'll see over the course of the next 2 days, and that's integral to how we think about it here at RELEX as well. The other is because that's where the industry has focused on. That's where the real value is in terms of driving some of these concepts forward. But that's not to say that it isn't relevant in other areas of operations and merchandising across the whole sector as well. And we will touch on some of those elements in a couple of slides' time. So the other real powerful element that's helping kind of enhance decision making is the huge calculation power. And when we augment that alongside user insight and experience, that really drives better decision making across the whole sector as well. And then finally, the ability to automate some of those processes and allow our users, again, to focus on the business critical elements. Again, we want to think about this not just from a retail setting, but also from a DC and a wholesale perspective as well, whether it be management of sales channels across geography, banner, customers, or a combination of those factors. So all these elements are combined when thinking about how AI and machine learning can actually help us. Okay, so the variability component. Now, this is a key concept in my view to how forecasting works from an AI and ML perspective. So it's not going to surprise you about the core components of what a forecast actually is and does. The core principle is that we want to assess and predict what is typically unpredictable. So there's 3 components to that. The first is known variability. So an event or a trend or weather is a key example of a known variability. We know that it's going to impact the forecast and therefore it's going to impact sales. We don't necessarily know how or by how much. For instance, when we think about weather, it could typically have a positive effect, but it also could have a detrimental effect to our sales performance. The next part of that is planned variability. So this is when we're thinking about promotions or price or something of that nature, where there's a directional idea of exactly what the improvement will be, and it generally is upwards, right? So that's another area that variability comes into play. And then the third and final component of this is unknown variability. Again, some of the situations we've seen in the last couple of years pertaining to COVID have shown us some of these situations, but it goes beyond that with localized events or even assortment changes or other display settings, things like that that have an impact on how we sell that we aren't necessarily able to predict or even have insight or knowledge of. So the real area where AI and ML improves and helps us in this process is that it improves the accuracy of the basics of the known variability. It allows us to account for the exceptions in the unknown situations or the promotional aspect. And it allows us to deliver holistic accuracy from the most granular level, to take that localized and store-specific or DC-specific demands influencing signals and incorporate that throughout the network as well. So that's what we've seen in some of our interaction with machine learning models as opposed to time series. And to be able to add benefit across the 3 of these factors, including the unknown, which is previously something we've not been able to account for, is a really powerful place to be. Okay, so I did mention that forecasting is the predominant use case, but it does touch other areas of what we're trying to do from an operational or planning perspective. Let's take promotions, for instance. So one thing that we're certainly looking at from a RELEX perspective and the industry as a whole is localized event feeds, where we can understand the most granular level of details, incorporate that into our forecasting process, understand how that influences our forecast and where our inventory fundamentally needs to be. But then there's other things like promotional planning, where we assess the performance and we group that with a margin target, for instance, or a performance target to really understand what promotion is going to drive the impact that I need to see. Then there's other things like price elasticity, again, taking that into account when thinking about how I forecast demand. Capacity management is another component where machine learning can come into play. We've seen it through automatic delivery flow smoothing across DCs and store locations, where we synchronize and optimize delivery alongside labor and resourcing. And typically this would utilize a particle swarm analysis or a similar type of machine learning algorithm that really assesses how to smooth and how to distribute inventory across the network. That leads us on to network optimization. And this is a little bit further ahead in terms of a roadmap item. It's a very complex area, but we're starting to touch on things like dynamic delivery deployment and understanding where and when it makes sense to deliver into certain locations, maybe on a more localized setting as opposed to regional and things like that. And that leads us into balancing our inventory across the whole supply chain and the multiple nodes that go alongside that. ML algorithms are going to help us in deciphering that in the future for sure. Then we have omnichannel, another key component that's arisen in the last couple of years. So that leads us to zip code level forecasting and projected units per delivery, which help us link in with the transportation process that's integral for any e-commerce or omni-channel activity as well. Then assortments and clustering. So K-means algorithms have been around for a long time in this area, but there's more techniques to really understand how we localize assortment based on whether it be demographic or other criteria of that nature. And then also store operations. And typically this would be based around something like predictive control theory for managing perpetual inventory, or it'd be reinforcement learning, where we interact with stores and learn from their interaction with the product itself. And that helps us to drive better inventory, better forecast going forward as well. So many areas where ML can really help us. And I guess my key concept and idea here is, while we're focused on forecasting, we've already discussed that forecasting touches all these different areas, AI will really come into play across the whole holistic operational platform. So we think of demand as well as operations and merchandising. At some point, they're all going to be touched by ML and AI, whether it be from an algorithmic component, whether it be from data mining or whatever it may be, to get us to a better result. Now, you'll notice the title for this session is a pragmatic guide. And whilst machine learning and AI is intrinsically very exciting, at RELEX and myself personally believe that we have to have a bit of a pragmatic approach when thinking about how to apply AI. We'll touch on that in a few different ways going forward, but there's a lot of complexity involved, and we need to make sure that it's built on the right foundation to really drive business benefit, and that it's solving specific issues that we've historically seen within the supply chain network, rather than being seen as more of a fanciful strategy going forward. And I'll touch on that a bit more later. Okay, so how does it actually work? Well, at RELEX, we've adopted what we call a Bayesian regression model. So with RELEX, that's more of a framework for exactly how we work with the algorithmic components of a forecasting model. The reason for this is that Bayesian allows us to be very flexible and configurable. It means we can add in multiple different variables. Basically anything that we can logically read in as a data source can be considered. That is, but in its very nature, has downfalls as well as being a very beneficial process for going forward. It's also scalable. The other thing we always need to remember when we're thinking about AI and some of these complex and advanced technologies is, will it work within a retail or wholesale setting whilst allowing the user experience to still be positive? It needs to be performant. It needs not to be too computationally expensive. And fundamentally, it needs to work and solve the problems, which is what we've found in our research and development process. The other factor of why we've chosen this as well is due to its ability to be very configurable, but also transparent and explainable. if you've used RELEX in the past, you'll know that's a key ideology for us, is to make sure that once the decision or once the system has performed a calculation, the user is able to really understand exactly why that's happened and what impact that it actually has. And again, this allows us to do that. So with any ML or AI algorithm, there's an importance in what we call regularization. And really, this is a methodology to simplify the models where applicable and make sure we have the right balance. So what that means is to get a good balance, we have to consider the potential of overfit. And an example for this is you're taking an exam. What you do is you memorize all the historical answers and questions. So when you take the exam and the questions are different, you actually don't know what to put. That's an idea of being having too high a variance over time. Now, the opposite to that is underfitting, and that's when you have too high a bias. And an example of that might be that you're assessing dogs for whatever reason, and you identify that there's two types of dogs: large dog, golden retriever, and a small dog as a chihuahua. Then you encounter a beagle, and you automatically think that it's a chihuahua because you only have 2 frames of reference. Now, as I own a beagle, I know she won't be too impressed with that. So the idea is that we get a good balance. An example of that is that if you lose your phone, it's most likely going to be in the kitchen or living room because they're the rooms that you've been. You think that fundamentally, but you don't rule out the possibility of it being in your car, as that is a location that you visit within your daily activities. And that's the idea of what we're trying to do here. We're trying to make trade-offs against the variance, against the bias, to make sure we have a fundamentally solid model to build upon going forward. Now, another component and area that's really exciting that we're doing using at RELEX is the idea of change point detection. And this has been integral in some of our piloting and development, particularly with COVID involved as well. So the idea here, and again, relating back to that unknown variability that I mentioned before, is that we're trying to identify step changes where it makes sense to be slightly more reactive to what's going on. So this would typically be things like we have an additional off-shelf display at a particular location. How does that impact the forecast? Historically, it might be something that we don't notice for a week or two until the spike doesn't go away, or whatever it may be. Or it might have been smoothed out as an outlier. With machine learning, we're able to actually identify those instances and account for them where applicable, which obviously is going to allow for a lot greater accuracy going forward. And again, when we saw some of those spikes and dips related to COVID, we saw a quick reaction to some of our ML models that much exceeded what we would typically see from a time series perspective, and really helped us add both percentage points in terms of forecast accuracy, but obviously then availability, which is the crux of what we're trying to do here as well. Okay, so this next slide, if you don't have a large screen here, it's going to look like a lot of lines and a lot of dots. Fundamentally, that's what it is. So these are pulled directly from the RELEX system, and it shows examples of where ML and AI really comes into its own and really drives a lot of business benefit and accuracy. So things like strong events, where an item is a continuous seller, but when it sells well on promotion, it really exceeds performance, or exceeds what the typical mean would be. This is an example of where the ML and the fitting process can really drive a lot more accuracy. Then we have things like strong trend, which would typically be difficult to ascertain. Again, it's a corner case or a use case where ML is able to adapt very quickly and therefore forecast that in a much more accurate manner. Then we have something like complex seasonality, where something's not as we would like it in the typical peak and trough, and is actually fundamentally much more complex like that. This is another area where the ML algorithms exceed what we would typically see from a time series perspective. And then extreme seasonality, which has been the bane of retailers' lives since the dawn of time, is really to understand if a product doesn't sell anything typically throughout the year other than a couple of periods, or maybe it's something like Halloween or products that have of that nature in assortment. And again, this is an area where ML can really identify and drill down into those instances in the past and use that as calculation logic going forward, whereas time series wouldn't necessarily be able to account for that. And there's different components and strategies within that, within the ML framework that we've discussed. So these are some examples. And the other factor here is that we can take in multiple examples of that. So whether it be a trend component alongside a strong event, for instance, the RELEX system through our ML approach can identify this is exactly the coefficient that related to the event. This is the coefficient related to the trend. This is how the two correlate to one another. And you can really understand the impact at that granular level. Okay. Now I'm going to add some British cynicism and pragmatism to the discussion and dampen some of the hype, and then I'm going to ramp it back up again. So here we go. So pragmatic approach, and what I mean by that is that you have on the left all these different factors and many more that all work in tandem with one another, that contribute, they're all demand influencing factors. They all correlate with one another, and typically you would have to make trade-offs between them. That's something that we're focused on from a development standpoint to make sure that you don't have to make those trade-offs and you don't have to have those limitations. But it's still a consideration that we always need to be cognizant of. And on the right, you have the kind of bell curve for the gains that we see from that. And what we really want to make clear here is that there's so much value we can drive from a baseline perspective, adding on holidays, price, promotions, and weather, that at some point the gains become marginal, but the complexity exceeds that. Now that's becoming less and less every day as we develop a process. But without the right strategy and without the right foundation, we can quickly get ahead of ourselves and not drive the right benefit that we think we are. So again, a pragmatic approach and a solid foundation is fundamental to making sure we get the most benefit out of machine learning algorithms throughout retail, wholesale, and manufacturing. Okay. So future state, something that I have to touch on, and it's where we're potentially going in the future and how machine learning and AI will interact from a retail perspective, wholesale, manufacturing in the future. So the first one is localization and personalization. I think this is a key component of any strategy that we see in the industry. Partly this is driven by additional data that we can source, we've already discussed, and we will discuss in a couple of slides' time as well. But it also extends all the way through to how we currently interact with stores. Things like facial recognition to target sales channels later down the line, i.e. we use stores as more of a showroom and then you purchase it online. Things like that are coming into play or will come into play in the future. Quantum computing, so this is what I predict might be the next buzz phrase in the industry. And this is basically different computational systems to solve complex problems, but it sounds really fancy. Robotics, we're already seeing things like shelf-edge interactive ticketing, image recognition, as well as even inventory robots. So they're coming into play. And for a system like RELEX, it's really how do you integrate with them? And typically that would be looking to do that in a real-time manner. Then interactive reinforcement learning. So real-time learning based on the environmental factors or based on human interaction with some of these machines. Synthetic data. Now, this is typically seen in things like self-driving cars, where we want to train a lot of data quickly, and the data isn't typically widely available. So I think this will come into more prominence as we try and get more accuracy with some of the models and some more of the advanced models as well. Then capsule networks. So this is a subset of neural networks which utilize deep learning. These are very computationally expensive today. And we're exploring them in a lot more detail going forward. And there's solutions needed related to pooling and routing. And when they become more readily available, this will be commonplace going forward, or certainly I think so. Okay, so let's finally touch on how it's actually applied, and how we see it being applied at RELEX. So I already touched on and mentioned the pandemic, and it would be remiss of me not to mention that again. So we obviously saw huge dips, huge spikes based on category, based on the product level. And that had a knock-on effect on availability. Sometimes we weren't able to even source the product. However, through the Demand AI RELEX platform, we were able to understand, or we were able to leverage that to increase accuracy by between 1 to 4 percentage points on average. So really the value of that is it allows planners to focus on other forward planning activities. And that's typically the associated value with something like Demand AI. We have more trust in the forecasting process, and it allows users to utilize their expertise in other areas, whether that be promotion, whether that be forward planning, whether it be more on the replenishment and inventory management side of things. Then something like fresh and day level forecast accuracy. So fresh is obviously a key component of what we're trying to do at RELEX and the problems that we're trying to solve. And there's a lot of factors that go into managing fresh that make it very, very difficult. One thing that we need to consider is day level or even intraday level forecasting. So something we do at RELEX is we can break that down to 15-minute increments to really understand the sales pattern across the course of a day. And what we saw in some of our piloting research was an improvement of 9 percentage points at peak times in December around Christmas, which is obviously has an integral knock-on effect onto our sales performance. This also allowed us to see longer-term demand changes that are not necessarily attributable to seasonality or anything else. And again, going back to that variability component I mentioned before, is something that ML really does provide benefit above and beyond what we're typically able to do in traditional models as well. Then weather. Weather is always a key use case when we think about machine learning and AI. It's because there's a very clear, tangible correlation between, let's say, something like temperature and sales performance. Now, with weather, it's interesting as it goes both ways, right? You can have good weather that improves performance. You can have poor weather that degrades the performance. And what we've seen is by taking that into account, we were able to have 20% less wastage, less spoilage, alongside reduced forecast error of up to 75%. So that's pretty significant. That allowed us to really capitalize on some of those weather-driven sales. And as a Brit, we know that's all important because we only get about 3 weeks of good weather a year. Then finally, I mentioned it before, but external data sources. So we have the use case where we incorporate footfall information, upcoming footfall information at airport and railway locations to help the customer generate their forecast and do the correlatory analysis between what's happened when the footfall gets to a certain number. So this obviously has led to a lot of significant improvement in spoilage, as well as increased availability for those time periods. And it really opens up the discussion for the data that we can consider. I mentioned localized events, but there's really no limitation to what data that we can consider, as long as it's built on that solid foundation. So they're just some of the ways that we have taken AI and machine learning into account and into place at RELEX. There's many other ways that we can touch on and go into detail. But in conclusion, I just wanted to kind of finalize with these thoughts. So the first thing is that AI and ML is not going away. It's going to be at the forefront of what we do, not just in retail, but wholesale, at a DC level, at a store level going forward. And also, AI should solve a problem, and it should solve it effectively. What I mean by that is that the importance cannot be understated, but it needs to be a tool within a data strategy rather than the holistic data strategy itself. It would be dangerous to think that we're gearing all of our solutioning towards ML rather than thinking of the problems that we're actually trying to solve. Then also, computational processing power cannot be ignored. What I mean by that is at RELEX, we're looking at horizontal and elastic scaling to make sure that performance is always at the top of our game. It's something we pride ourselves on in the industry. But the more complexity we add, the harder that becomes. And at some point, we need to consider that as a kind of more general way of thinking. So it cannot be ignored, and you have to ensure that the user experience and the performance goes hand in hand with that, something we're very focused on and so far been very successful with. And then finally, we're at the start of the AI journey. We don't know what it's going to look like in 3 to 5 years as these things are developing almost overnight. So it's a very exciting place to be. And hopefully next year or the year after, I can come back and tell you about all these other new and exciting methodologies that we're incorporating, not just to forecasting, but across the whole supply chain solution area. So that's me. Any questions from the audience?
Thank you so much, Josh. So many great insights. And I mean, it's incredible to really see how retail planning leaders and data scientists are moving retail forward, with machine learning algorithms to keep up with all the fluctuating consumer demand levels, even during disruptions like we've seen in the last 18 months. So an interesting question came in from the audience. And so I want to ask you, which of the technologies like inventory robots or image recognition are the most important in retail right now?
Okay, interesting. So I would say something like image recognition is very important because there's a key value adds there. Planogram compliance, for instance, is something that's going to add a lot of benefit to a business. Anything where we're thinking about resourcing and labor at the store perspective is going to have a cost associated with it. So I think that's an integral part of that. Inventory robots is obviously a very interesting idea, and there's so many other technologies that are influencing how we think about this. But I would also bring that back to the pragmatic approach. Right, there's a lot of gain to be had from doing or applying it to the basic foundation. And what I mean by that is if we get our baseline forecast correct, that's going to drive so much more value. A forecast accuracy improvement of 5 to 10%, the knock-on impact to inventory and availability, reduction of lost sales, increase in performance. That's going to be where the money is, where the cost savings are as well. And then everything after that is a really nice kind of benefit on top.
Absolutely. And it's so interesting. One of the biggest questions that we have around technology is the impact on the workforce. So another question that we have is, what will that impact be on the workforce? Will planners and store ops be replaced?
Well, I mean, so at a retail standing, we've already seen some companies move towards the kind of cashierless checkout and things like that. At RELEX, I think we want our technology to augment user experience and knowledge. We don't want to ever consider replacing planners. We want them to be more empowered to do their jobs in the most effective way. So while to some degree, some companies are focused on that from a technology standpoint, I think we always need to appreciate and work with the human aspect of that. And there's things like the reinforcement learning that go hand in hand with human input. So all of our algorithms can actually learn by what the store operative or planner at a central perspective interacts with these systems as well. So there's definitely benefit from not thinking of it as a kind of replacement for planners or store operatives going forward.
Well, and it's amazing to think about how they can work together. And I like the word that you used, empower, right? We need to empower our teams to be able to utilize these technologies to do more and to innovate, which is what Miko was talking about earlier on in the session today. So thank you again, Josh. Let's take a break and we'll meet you back here at 10 after 3 Eastern to get smart with PetSmart.